If two curves intersect internally or externally, this is internal intersection. Just a minute. Internally intersecting. Now you draw two secants. They're intersecting externally. Whether they intersect internally or externally, at the point O, and I'm taking the two curves as AB, CD. They're intersecting at point O. Point O is not a center of the circle. It may be a center or may not be a center, it doesn't matter. It is AB and CD. They're intersecting at point O or point E, whatever the point it may be, you can take any point that you want. But the formula is what? OA into OB is equals to OC into OD. Okay, OA into OB is equals to OC into OD, right? One more thing here. Usually angle at the center, or else if I take an angle here, if this angle is 30 degrees, can you tell me what about this angle and this angle and this angle and this angle? How much it is? 30, 30, 30, 30 only. You can take it anywhere in between these two lines. You understand that? You can take the angle anywhere in between these two lines. Okay. Suppose I'm giving you this angle. It is 10 degrees. If you are looking at the angle, okay, by using a magnifying lens, which magnifies everything into 5 times. Okay, you're seeing from a magnifying lens, which magnifies everything into 5 times, 5x, right? So if you look at 5x, what is the angle between the two lines? By using a magnifying lens, if you look at this angle between the two lines, what would be the angle then? It is same. Yes or no? Even if you put magnifying lens, the lines, angle between the lines is not going to change. It appears a little bigger, but angle remains the same. You understand? So if I take an angle from the center, let's say OB, or else angle AB is same as what? Angle AOB. You understand that? If two curves bisect internally or externally, there O is a center, here O is not a center. Okay. So if I ask you this angle, okay, if I ask you this angle or this angle, theta is equals to angle subtended at the center, that is AC, this angle and this angle. By 2. You understand? Okay, angle subtended at the center here and center there by, if I ask you this angle, this is AC minus BD by 2, or else take it as 5. Angle theta is what? AC plus BD by 2. Okay. In the same manner, what is angle BD? Sorry. So angle in the first one is AC plus BD by 2. Here it is AC minus BD by 2 angles. And as well as this one you must remember. One tangent and one chord is drawn. A tangent, a secant is drawn. It is TOAB. Okay. A into OB is equals to OT square is the formula where OT is the tangent. If I take this angle as theta, AT minus BT by 2. What is it? AT minus BT by 2. So angle subtended at the center by AT, angle subtended at the center by BT by 2 minus the difference in the angles by 2. Suppose if this angle is 150 at the center and this angle is 30 at the center, 150 minus 30, 120 by 2 is 60. Therefore, it will be what? 60. Like that you have to take it. If you draw any triangle in such a manner that one vertex is center, other two sides on circle. One vertex is what? Center, the other two are on the circle. What kind of a triangle it is? You can say OA is equals to OB is equals to radius. Therefore, triangle OAB is what kind of a triangle? Always remember, if the triangle is drawn at the center, it will be what kind of a triangle it is? It is isosceles triangle. Okay. If I draw a quadrilateral, ABCD is a quadrilateral. ABCD is inscribed in a circle. Therefore, you call it ABCD is cyclic quadrilateral. Angle A plus angle C is equals to 180 degrees is same as angle B plus angle B. Sum of opposite angles is equals to 180, or else you can say opposite angles are supplementary angles. Sum of opposite angles is equals to 180, opposite angles are supplementary angles. If I draw from center to the point of contact, we know it is perpendicular. Now see here. If I take this angle as theta, anyone tell me what is this angle? What about that angle? This entire thing is 90 degrees. It is theta. Therefore, what is this angle? 90 minus theta. And what about this angle? 90 minus theta. What is it? 2 theta, because sum is 180. If it is 2 theta, then what about this? It's also theta. Understood? So to tell you simply, angles in the alternate segments are equal. If it is theta, this is also theta. If it is phi, now what about this? This is also, this is called alternate segment theorem. Just copy them. Alternate segment theorem. angle between tangent and a chord. Tangent and a chord at the point of contact. At the point of contact. Is equal to angle in the alternate segment. Is equal to angle in the alternate segment. Right. See at the center, if it is 2 theta, then what about this? This one is theta. So I can say if I take it as theta, if it is a chord AB, can I say theta is equals to what? AB subtended at the center divided by 2. The angle subtended by the arc AB at the center is 2 theta. It is theta by 2. So you can say so. Theta is equals to what? Angle subtended by the arc AB by 2. Okay. If suppose this center angle is given, then what about this angle? It is half of the angle subtended at the center. Taking common tangents. If two circles are external to each other, when they're touching externally, when they're intersecting, touching internally, one circle is completely inside the other. What are the number of common tangents? Here I can draw how many common tangents? 1, 2, 3, 4. The horizontal lines are direct common tangents. Okay, these crossed lines are transverse common tangents. When they're in touching externally, you can draw 3 common tangents. When they are intersecting, you can draw 2 common tangents. When they are touching internally, there is only 1 common tangent you can draw. When one circle is completely inside the other, can you draw any common tangents? No, you cannot draw any common tangents. Right? If one circle is completely external to each other, what do I call? It's called a direct common tangent. Okay, how do I find out the length of direct common tangent? Radius 1, radius 2. Distance between the centers, I'll take it as D. I'll draw a line parallel to C1, C2. So what are the things that they give you? They give you C1, C2 distance they'll give you. I'm assuming C1, C2 is the distance between the centers, that is D. If it is D, you are drawing a line parallel to it. It is also what? D only. Now see here, we know it is perpendicular at the tangent. Okay. Now you can say it is entire thing is R1. This thing is R2. What is this space? That space is R1 minus R2. Length of tangent is L. Now look at the right angle triangle formed there. What is opposite to 90 here? It is D. So what is the formula? I would say D square is equals to L square plus R1 minus R2 whole square. Therefore, what is L? L is under root of D square minus R1 minus R2 whole square. You understand that point? So what is the length of direct common tangent? This one is direct common tangent. Length of direct common tangent is L is equals to under root of D square minus R1 minus R2 whole square. What is D there? D is the distance between the centers. Suppose if two circles touch each other. Therefore, D becomes R1 plus R2. D square minus R1 minus R2 whole square becomes R1 plus R2 whole square minus R1 minus R2 whole square. A plus B whole square minus A minus B whole square gives you 4AB. 4R1 R2. Because A square, B square cancels. 2AB, 2AB. So that is 4AB. 2R1 R2, 2R1 R2. So 4R1 R2 will be left out. Therefore, what is the length? Under root of 4R1 R2, which is equals to 2 root of R1 R2. This is the length of direct common tangent. If I take transverse common tangent, take the two circles like this. This we call it as a transverse common tangent. This one is R1. This one is R2. This is L only. Now this is distance between the centers. Now you tell me. This one is R1, R1, R2. This is D. C1, C2 is D. 90 degrees, and this is L. Of course, L square is equals to D square plus, it is R1 plus R2 whole square, right? D square minus, I'm sorry. Okay, so therefore, what is L? L is equals to under root of D square minus R1 plus R2 whole square. Same formulas, but here it is R1 plus R2. Okay, for direct it is R1 minus R2, right? So length of direct common tangent, length of transverse common tangent. 41 and 42, if you look at. Two circles of radius 7 centimeter and 2 centimeter. Their centers are being 13 centimeters apart. Then the length of the direct common tangent. So what is D? Distance between the centers is 13. R1 is 7. R2 is 2. Therefore, L is under root of 13 square minus 7 minus 2 whole square. What is 13 square minus 5 square? It is 12 square. Therefore, it is 12. Direct common tangent means R1 minus R2. Transverse common tangent means D is equals to how much here? The distance between the centers of the two circles, each of the radius 3 is equals to 10. What is R1 is equals to R2 is equals to 3. Therefore, what is L? D square is 10 square minus R1 plus R2 is 6 square. 100 minus 36 is 64. 64 root of 64 is 8. Simply using the formulas under root of D square minus R1 minus R2 for direct, R1 plus R2 for transverse. Copy them. If an equilateral triangle is inside, it circumscribes a triangle, or else it is inscribed in a triangle. In both the cases, what is a triangle? What kind of a triangle it is? It is equilateral triangle. For the first one, the side of the first one is A only, but the radius is capital R. Yeah. If the circle is outside, you call it as a circumcircle. If the circle is inside, you call it as a incircle. So here, triangle circumscribes a circle. In the second one, triangle inscribes a circle. So circumradius is capital R. What is circumradius? Capital R, side is A only. In radius is small r, side is A. What is the relation? A is equals to root 3 times of capital R. A is equals to 2 root 3 times of small r. Therefore, if you equate both of them, capital R is equals to 2 times of small r. What is capital R by small r? Circumradius by inradius is 2 is to 1 for the same triangle. And here ABC is what kind of a triangle? ABC is equilateral triangle with side A. What is area of circumcircle by area of incircle? If radiuses are in the ratio, radii are in the ratio 2 is to 1, areas will be in the ratio 4 is to 1. Understood? Now, if a right angle triangle a triangle is inside an, okay, a triangle is inscribed in a right angle triangle, sorry, inscribed in a circle. Next, a circle is inscribed in right angle triangle. It is not only in the middle, it can be anywhere like this. Okay, in the first one, what kind of a triangle it is? C1, C2, C3. All of them are right angle triangle. If a right angle triangle is inscribed in a circle, hypotenuse is equals to what? Diameter. Area is equals to, area of a triangle is half into diameter is 2r into the radius. The maximum area will be r. This is maximum area. So the maximum area of right angle triangle which is inscribed in a circle is r square. Okay. What is the maximum area of a right angle triangle which is inscribed in a circle? It is simply r square. It's a right angle triangle which is inscribed in a circle. And remember, what is the important thing? Diameter is nothing but hypotenuse. Okay, the other one. If suppose if a circle is inscribed in a right angle triangle, we know length of tangents are equal. We know that it's a radius. It is also radius 90, 90, 90. Therefore, obviously, this also becomes what? 90. It becomes the square of side R, 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 R. We know this entire side is A. If you take out R, it becomes A minus R. If this entire side is B, if you take out R, it will be what? B minus R. Now, length of tangents are equal. Therefore, A minus R equal to A minus R. B minus R is equals to B minus R. But this entire length is, I say third side is C. Now, what is C is equals to A minus R plus B minus R. 2R is equals to A plus B minus C. Therefore, R is equals to A plus B minus C by 2. Okay. For a circumradius, what is the circumradius? Hypotenuse by 2. For a right angle triangle, circumradius is hypotenuse by 2. What is in radius? A plus B minus C by 2. Side 1 plus side 2 minus hypotenuse by 2. This is for a triangle and as well as a circle. Now you look at circle and a square. A square is inscribed in a circle. A circle is inscribed in a square. Let the side of a square is same in both the cases. For the first one, it is what? Diagonal of a square is equals to diameter of the circle. Therefore, A is equals to root 2R. Side of a square or edge of a square is equals to the diameter. Right? Therefore, root 2 capital R is equals to 2 small r. A is equals to root 2 small r by r. Circumradius by inradius for a square is root 2 by 1. Area of circumcircle by area of incircle for a square is 2 by 1. If radii are in the ratio root 2 is to 1, area will be the square of it. That is 2 is to 1. In the previous case, for a triangle, what is the radius? In radius and circumradius, or circumradius and in radius? 2 is to 1. Here it is root 2 is to 1. If a square is inscribed, then the side of a square is equals to root 2 times of r. If a circle is inscribed, then the side of a square is equals to 2 times of small r. Remember, for triangle, it is root 3 times of capital R and 2 root 3 times of small r. For a square, it is root 2 times of capital R and 2 times of small r, right? If a rectangle is inscribed, then the diameter of a rectangle is nothing but what? The diagonal of a rectangle is diameter of a circle. That's not a big deal, okay? But if any quadrilateral touches, if a circle touches all the sides of a quadrilateral, suppose 1, 2, something like 3, 4. A circle touches all the sides of a quadrilateral. Let's take the length is A. Therefore, it is also A because length of tangents drawn from an external point is same. If it is B, this is also B. If it is C, this is also C. If it is D, this is also D. See here. A, B, C, D. Look at the sum of opposite sides. What is the sum of opposite sides? This is C plus D, A plus B. So what is BC plus AD? A plus B plus C plus D. Look at what is AB and CD. A plus B plus C plus D only. So when a circle touches all the sides of a quadrilateral, then sum of opposite angles, sum of opposite sides are equal. AB plus CD is equals to BC plus AD. Is that clear? When a circle touches all the sides of a quadrilateral, sum of opposite sides are equal. They may give you the same question, but without that AB and CD, if they give you like this, they don't give you the figure, but they'll give you, suppose if it is 6, 7, 8. What about this? That is also 7 because 6 plus 8 is equals to 7 plus x is equals to 7. You understand the point there? So when one circle is inscribed in the other, having the same center, you call them concentric circles. Concentric circles means circles with the same center, but different radii. Small r, capital R. What is the area of the ring? Shaded area is pi, capital R square minus pi, small r square. Pi you common, capital R square minus pi r square. Or else you can take it as pi, capital R plus small r into capital R minus small r. If two circles are intersecting in such a manner that the centers of two circles passing through each other. Two equal circles whose centers of each other. Two circles passes through the centers of each other. C1, C2. Radius. If they intersect A and B, what is it called? Radius, radius. This is called length of common chord. AB is equals to, can I say 2 times of AO? So midpoint, right? And triangle AC1, C2 is what kind of a triangle? Is equilateral. Then area. What is the area of an equilateral triangle? So we don't need area. Okay, we need just height. What is the height of an equilateral triangle? Height OA is equals to root 3 by 2 times of R. Therefore, AB is equals to 3 times of R. Therefore, call it length of common chord is equals to what? Root 3 times of R if the radius are, radius of both of them are equal and if they passes through the centers of each other. Let's say if they doesn't passes through the centers of each other. If they are not passing through the centers of each other, how do you find out the length of the chord? This is AB, O. Here AB is equals to what? 2 times of AO, which is 2 times of height of a triangle. Understood? This one is C1, C2. Radius 1, radius 2. Distance between C1 and C2 is D. Understood? So you take half into base is D into height is equals to use the formula under root of S into S minus A, S minus B, S minus C. Therefore, you can find out height is equals to 2 by base area. Therefore, find out the height. After finding the height, you want to do what? AB is equals to 2 times of height. Understand how do we find out height? What they'll give you? They'll give you R1, they'll give you R2, they'll give you distance between the centers. So by using these three, find out the height. How do I find out the height? Half into height into base is equals to area of a triangle. How do you find out the area of triangle? By using under root of S into S minus A, S minus B, S minus C. Okay. So like that, you can just find out the height. Double the height, you will get the length of common chord. Okay. Copy that. ABC is a right angle triangle with a hypotenuse AC in it. AB is equals to 6, BC is equals to 8. Two sides are 6 and 8. Therefore, what is hypotenuse? Hypotenuse is 10 because we know 6 square plus 8 square is 10 square. The circle with the center O has been inscribed in the triangle. Okay, what kind of a triangle it is? Right angle triangle, and the circle with the center O is inscribed in a triangle. Then what is the in radius? A plus B minus C by what? 2. I don't need to draw the diagram because we know already. 6 plus 8 minus 10 divided by 2. What is 4 by 2 is? It's 2. Is that clear? A radius of a circle is R and the two chords of it are PQ and PR such that PQ is equals to 2 times of PR. If the distance of PQ and PR from the center of the circle be P and Q respectively, then which of the following is correct? Which chord is the greater chord or the larger chord? Obviously, PQ is the larger chord because PQ is 2 times of PR. So draw two chords from the same point. I'm drawing two chords from the same point. One is PQ, another one is PR, and the distance between the centers is given P and Q. Radius is also given. I'm taking it as PQPR. Distance between center to the chord PQ is P. Distance between the center to the chord PR is what? Q. Let this be A and this be B. Can you tell me, if I assume PA is equals to X, then what is PR? 2X. Therefore, what is PQ? 4X. Therefore, what is PB? 2X. You understand that? I'm assuming half of the chord is X. Therefore, half of the other chord becomes 2X because it is double. Okay. Now the radius is R. Tell me what is the first right angle triangle? The first one, what is it? P square plus 4X square is equals to what? R square. Second one, Q square plus X square is equals to what? R square. First take the second one, then take the first one. Multiply the second one with what? 4 and subtract. Sorry, multiply the first one with 4. Tell me what happens. 4Q square minus P square is equals to what? 3R square. Therefore, 4Q square is equals to what? P square plus. My aim is to eliminate X. How do I eliminate X? Multiply the first equation with 4 and then subtract the second. 4x square cancel. 4q square minus p square is equals to 4r square minus r square gives you 3r square. Therefore, 4q square is equals to p square plus 3r square. I'm starting the sum by assuming that PA is equals to x. Therefore, PR becomes 2x and PQ is double of PR. Whatever the half of the chord here, that becomes double there. The diameter of the circle is 20. On both the sides of a center, there are two chords, each of which are 8 centimeters from the center. What is the length of each chord? I don't need to draw both the sides. I just need to draw one side, that is enough. If diameter is 20, what is the radius? If diameter is 20, radius is 10. And what is the length of the curve? What is the length of the curve? 8. So 8 centimeters away from the center. Each of the chord is 8 centimeters from the center. Sorry. The distance between center to the chord is what? 8. And you tell me what is the diameter? 20. Therefore, the radius is 10. According to the Pythagoras rule, it becomes 6. PB is equals to under root of 10 square minus 8 square, that is 6. So therefore, AB is equals to how much? 2 times of PB, which is 2 times of 6. That's 12 centimeters. By imagining the figure, you can just answer this. Copy. AB and CD are two parallel chords. See, when two parallel chords question comes, it's always have to something to do with the Pythagoras rule. Okay. AB and CD are two parallel chords on the opposite sides of the center of the circle. If AB is equals to 10 centimeters, CD is equals to 24 centimeters, then the radius of the circle is 13. The distance between the two chords. Is given. I'm taking another side like this. Take this. This is opposite side. Suppose if it is same side, how it appears? It appears like this. One chord here, another chord here. Distance between center to the two chords. The radius, the radius. Everything has to deal with Pythagoras rule only. See there. Radius is 13 and 13. Half of the chord is 5 and half of the chord is 12. Tell me, according to Pythagoras rule, what is the third side? 12. What is it? 5. Therefore, what is the distance between the two parallel chords here? Distance between the two parallel chords is 12 plus 5. If they are opposite side. If they are on the same side, this is 12, this is 5. Understood? Everything else is same now. 13, this is 12, this is 5. Therefore, it is 5, it is 12. So 12 minus 5 is how much? 7. If they are on the opposite side, it is 12 plus 5. If they are on the same side, it is 12 minus 5. Copy that. After that, take a break. The 32nd question. I'll read the question. Two chords AB and CD of a circle intersect at E and are perpendicular to each other. So you can imagine two chords AB and CD. They are perpendicular to each other and they intersect at E. Segments AE, EB, ED are of the lengths 2 centimeters, 6 centimeters, 3 centimeters, and 3 centimeters respectively. Then the length of the diameter of the circle in terms of centimeters. Two chords AB and CD. They intersect at what point? They intersect at E. We'll take it here. This is AB, CD, E. It is 2, 6. it is 3. Can I say 2 into 6 is equals to 3 into 4? Because 12, the product is same. We can say if the two curves internally intersect or externally, we say OA into OB is equals to OC into OD. Therefore, 2 into 6 is 12. Therefore, 3 into 4 is also 12. So it is 4. Because 2 into 6 is equals to 3 into 4. From a center to chord, if you draw center to a chord, it divides the chord into 2 equal parts. Can I say so? What is the length of the first chord? AB. AB length is 8. CD length is 7. What is 8 by 2 then? 4. What is 7 by 2? 3.5. If it is 3.5 and this is 4, therefore can I say it is 0.5? 0.5 means 1 by 2. I just need the radius. How do I find out the radius? R square is equals to 4 square plus 1 by 2 square. 16 plus 1 by 4. Root of 65 by 2. Now what is the diameter? Root 65. Okay. Copy that. AB is a chord of a circle with center O. So you can just imagine a circle with center O, and AB is the chord of that circle, right? DOC is a line segment originating from a point D on the circle and intersecting AB produced at C. Okay, so DOC is a line starting from D, passing through O and going up to C. It is produced, okay, it is meeting a line produced AB at C. So you can just imagine, first you can take a circle. You can draw DOC or DO. It is like this. It is meeting the chord AB produced at C. Ila draw చేసుకోవచ్చు. Understood? Tell me D, O, C, A, B, right? AB is the chord of a circle with the center O, and DOC is a line segment originating from a point D and a center, okay, on the circle of intersecting AB produced at C, such that BC is equals to what? OD. What is OD? Radius. What is BC? Radius. If I take E, OE is also what? Can I say it is also radius? BCD is 20. So this one is 20 degrees. Then AOD is how much? Can I join them? If it is 20, this is also radius. Therefore, isosceles triangle. Can I say it is also 20? Yes or no? If it is 40, I know this is 40 because external angle is sum of interior angles. This is also 40. Why it is 40? Because it is isosceles triangle. Can you tell me what about this? This becomes an external angle to the triangle this. For this triangle, it becomes an external angle. What are the two angles? 20 and 40. Therefore, it becomes 60. This is 20 plus 40. Understood? So I would say AOD is equals to OAB plus BCD. Right? If I want to show you everything in terms of theta also, I can show you. If everything you assume it as theta, in terms of theta, if you want to do it, See if it is theta. This becomes theta. This becomes 2 theta. This becomes 2 theta. At the center here, 3 theta. Is that clear? If it is 20, that becomes how much? 60. Two circles with the centers P and Q intersect at B and C. A comma D are the points on the circles with the centers P and Q respectively, such that A, P, D are collinear. So what are the centers of the circles? P and Q. They intersect at A and B. Take one is a bigger circle. Another is a smaller circle. They intersect at first centers. They intersect at A and B. And BCD are collinear. A, C, D are collinear. They intersected B and C. I'm sorry. They intersected B and C. A and D are the points on respective circles. One center is P, another center is Q. APB is given as 130. What is that he's asking? What is this angle he's asking? See here, if it is 130, can you tell me what about this? This becomes 230. Half of 230 is 115. Remaining is is asking you BCD. BQD is asking, I'm sorry. Now, 130, we know that it is 230. It is 115. It is 65. Half of, okay, double of 65 is 130 again. Let me take it again. If it is 130, remaining 230. This one is 115, 65. Double of 65, 130. So he's asking you BQD, how much it is? 130. Suppose I can take it in terms of theta also. If it is theta, this angle is 360 minus. This angle is 180 minus theta by 2. This angle is theta by 2. This angle is. So whatever the angle you take here, that also same. ABCD is a cyclic quadrilateral. Side AB is extended to E such a way that BE is equals to what? BC. What is extended? AB is extended. Take any cyclic quadrilateral. Base is AB, you take it. What is extended? AB is extended in such a manner that this is equals to this. A, B, C, D, BE is equals to what? BC, isosceles triangle. ADC is 70 and BAD is 95. Can I say if it is 70, this is also 70? I know it is theta plus theta, therefore it is 35 and 35. Sorry. It is 110. Therefore, it is 55 and 55. Because opposite angles are what? Supplementary angles. So 70 means it is 110. If it is 95 means it is 80. Fine. Therefore, it is 55. Why? Because if I take it as theta and theta, 2 theta is equals to 110. Theta is equals to 55. And is asking you what? Angle DCE is asking, that is 85 plus theta. How many degrees it is? 140. So opposite angle sum is 180. So it is 70 means that is 110. 2 theta is equals to 110, theta is equals to 55. Theta equal to 55 means 55 plus 85, how much is asking? It is 140. The tangents are drawn at the extremities of the diameter AB of the circle with the center P. If the tangent to the circle at the point C intersects the other two tangents at Q and R, then the measure of QPR. So the tangents are drawn at the diameter AB, extremities of the diameter AB. If this is diameter AB, there are two tangents drawn, and those looks like this. These are the two tangents drawn. From another point on the circle, another tangent is drawn which intersect the circle like this. So he's asking you what is that angle. See here. A and B. At C also you are drawing. It intersects the two tangents at where? To the center P. So it intersects at Q and R. This is Q and this one is R. He's asking you what is QPR. So you draw a line here like this. This is also a tangent we know, right? Triangle 1 and 2, what kind of triangles these are? Congruent triangles. 3 and 4 also congruent triangles. We know from an external point, if you draw two circles, two triangles, these two triangles are what? Congruent to each other. If they are congruent, if it is x degrees, what about this? This y degrees, this is also y. So at P, 2x plus 2y becomes 180. What is x plus y becomes 90. Therefore, what is QPR? X plus y only, right? So what is QPR becomes half of 180. That is 90 degrees over there. Copy. The tangents at 2 points A and B on the circle with the center O intersects at P. They intersect at P. Take it as A, B, this is P. Look at this. AOB and APB. I told you if this angle, if it is theta and this is phi, or else if it is x and this is y. What is x plus y? So already tangents means 90 and 90. Therefore, what is x plus y there? X plus y is 180. Is asking you APB. APB is how many parts? One part out of 6 parts. 5:1 ratio. If you divide, the two angles are 150 and 30. One angle is 150, another angle is 30 degrees. I told you this is property number 6. Look at the triangle, circles, you'll get that. Two circles having the radii or units intersect each other in such a way that each of them passes through the centers of each other. Then the length of common chord when each of the circle passes through the centers of each other. You remember the length of common chord? Length of common chord is 2 times the height of an equilateral triangle. So what is it? It is √3 times of r. Okay, we solved it. The radii of two concentric circles are 13 centimeters and 8 centimeters. AB is the diameter of the bigger circle and BD is the tangent to the smaller circle touching it at D and the bigger circle at E. A point A is joined to D, the length of AD is asking. First of all, you draw two concentric circles. He says that AB is the diameter. Right? So let this be A and B. He says BD is the tangent to the smaller circle, touching it at D and the bigger circle at E. So BD is the tangent to the smaller. It is touching the smaller circle at D, intersecting the bigger circle at E. And what you are joining? A point A is joined to D, therefore length of AD. You are joining AD, you want length of AD. So here I'm taking two extra things. This is the given thing, but I'm completing by joining AE and also by joining O is the center, you take it OD. Completing the figure like this. Can I say angle in a semicircle is a right angle? Yes or no? And D is a point of contact. If you draw a line from a center to the point of contact, it is perpendicular to the tangent. And if you draw a perpendicular, okay, this is C. BE is a tangent to the smaller, but BE is curved to the larger. If it is a perpendicular, means it is divide the curve into two equal parts. Therefore, you can say BD is equals to what? DE. Smaller circle radius is 8, bigger circle is 13. Therefore, BD is equals to DB or BD, doesn't matter. 13 square 169 minus 64 105. So ED is also how much? Root of 105. It is midpoint, this is midpoint. According to the midpoint theorem, it is half of the third side. Therefore, AE is what? 2 times of DO. According to midpoint theorem. Now by Pythagoras rule, what is AD? Under root of 16 square is 256, 105, 361. What is 361? 90. Okay, in the recent years also, in 2020 also, the similar question asked with the different values, but the question is similar. Chord AB of a circle C1 of radius root 3 plus 1 centimeter touches the circle C2, which is concentric to C1. If the radius of C2 is root 3 minus 1, then the length of AB. So AB is the chord of circle C1. Again, two concentric circles, you take it. But here AB is not the diameter, AB is the chord to the one thing and tangent to the other thing. AB is the diameter of the larger, chord of the larger, PO. This one is the capital R, this one is the small r. What is PB? Can I say AB is equals to how many times of PB? 2 times of PB. Now what is PB? Under root of capital R square minus small r square. It is in the form of root 3 plus 1 whole square minus root 3 minus 1 whole square. Can I say 4AB? That is 4 root 3. Therefore, PB is equals to what? Root of 4 root 3. That is 2 fourth root of 3. Because root of 4 is 2. Root of 3 is fourth root of 3. Therefore, AB is equals to what? 4 into 4 root 3. So that is the length of the chord. Finally, N is the foot of the perpendicular from a point P of a circle with the radius 7 centimeter on a diameter AB of the circle. So N is the foot of the perpendicular from a point P of the circle with the radius 7 centimeter on the diameter AB of the circle. Okay. If the length of the curve PB is equals to 12 centimeter, then the distance from point N from point B is, take a circle, take the diameter AB. From point P, see, it can be any foot of perpendicular. Point P can be here, foot of the perpendicular. You are drawing from point P. But where is point P in this? He clearly gives you that PB is equals to 12. Therefore, I'll take it somewhere here. Like this, I'll take it. So rest of it, I don't take. Now I'll take it. Now what is AB? AB is diameter. Length is 14. PB is 12. This is PN, foot of the perpendicular. We know it is 90 degrees because angle in a semicircle is 90 degrees. If it is theta, this becomes 90 minus theta or else phi. If it is phi, this becomes again theta, this becomes phi. Phi here is 90 minus theta. Hope you understand that. Now see what you want. You're just trying to find out the distance from N to B. I just want to find out NB, let it be X. Is that clear? Find out what is sine theta in the bigger one. What is sine theta in APB? Angle APB, what is sine theta? Opposite is 12, hypotenuse is 14. Find out what is sine theta in PNB. Opposite is X, hypotenuse is 12. Therefore, X is equals to 144 by 14, 72 by 7, 10 by 7 centimeters. Understood? I'm using sine theta in this. Sine theta is what there? It is, if you look at in APB, opposite is 12, hypotenuse is 14. So 12 by 14. If you look at in PNB, opposite is X. And what is the hypotenuse? 12. I'm equating the sine theta in order to get the value of X because I know that they are similar. You can use the similarity property also in order to get this. Right? Copy them.